Chapter 22 of the Romance of Modern Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Rita Boutros. The Romance of Modern Geology by Edwin Sharpe. Chapter 22 The Age of Mammals. The geological record is not perfect. There are breaks in it such as have not and may never be filled up, and it is because of these breaks that some of the divisions are made in geologic time. At present, the earth's crust has only been scratched for fossils. Great parts of Asia and of Africa and of South America remain to be explored, and they may in some future generation fill the gaps of our knowledge and render superfluous some of the divisions which geologists now place in the eras of the rocks and of the fossils. But so far as we know at present, there were real breaks in the history of the continents, perhaps not swift or sudden, but wholly changing the appearance and the life, vegetable and animal, of half a world, perhaps the whole world at a time. Many geologists believe that the secret of these changes lies in the core of the earth, and that, to use our old simile of the golf ball, when the tension and pressures inside the earth grow too much for its strength, something gives way, and the whole world begins to change, the continents sinking under the oceans and new lands arising. We shall not again consider this idea in all its bearings, or ask whether there is any simpler explanation to be found in the never-ceasing explosive tremors of the crust. But we shall only say that the last of these great changes set in at the end of the Chalk Age. After that era we arrive at the period among the rocks which, with all its subdivisions, Eocene, Miocene, Pliocene, Quaternary, is classed as Cainozoic or modern. Let us sum up the changes broadly. The Tertiary period, which now begins, has been called the Age of Lakes, but this merely means that there were great lake deposits. And it is true to say that as contrasted with a period of great waters, the Tertiary is to be considered as the period of land. That does not mean that there were in all the hundreds of thousands of years which it embraces no advances and retreats of the sea, no submergings and uprisings of the land. There certainly were. But the land was dominant, and it is the land animals and the land vegetation that are the most important and progress most. After the earth movements which occurred at the end of the Mesozoic or Secondary period, there appears to have followed a period of quiet. There was a considerable area of land standing high above the waters, and there began one of the minor but considerable encroachments of the sea in North America. It is probable that the Pacific and the Atlantic joined between North and South America. At the end of this first period, the sea withdrew again, and what is called the Miocene period began, with a lowering of the temperature of the waters of the Atlantic. And lastly followed the great extension of the land towards the north, the great withdrawal of the sea of Pliocene times, and the growing cold which led to the glacial era of the Pleistocene period. In Europe and in Asia we may note that the great areas which are now covered by the Alps and the Himalayas were at the beginning of the Tertiary period still under water, and only a few signs, in the form of islands, of these mighty ranges were beginning to appear. Preeminently, the age which comprises all these periods is the Age of Mammals. But one of the changes which European geologists first noticed was the surprising change which took place in the marine fossils. The animals of the sea, which were familiar during the chalk period, nearly all disappeared and were replaced by new ones. The great saurian reptiles, from the monsters of the land to the mosasaurus serpents of the sea, disappeared, and most other reptiles showed profound changes, showing a revolution in the animals of the land corresponding to that of the sea. Lastly, in this first period, the Eocene, mammals suddenly appear in force, and occupy the first place among the animals. The vegetation did not change so much as might have been expected. Whence came the mammals? That again is one of the questions which time alone can completely answer. But the opinion of most geologists is that they arose and developed in Asia first of all, and then spread to other continents. The rise of the mammals, which, unlike the reptiles, bring forth their young relatively mature and nourish and protect them, was contributing to the downfall of the reptiles, though it cannot be considered an actual cause. The mammals' young had a better chance of living and surviving than had the eggs of reptiles. Moreover, the mammals began with superior agility and higher brain power. It is not surprising, therefore, that the invasion of the mammals resulted in the clumsy, affectionless, small-brained reptiles being driven either into extinction or into the sedges and rushes, the swamps and lagoons, the coverts of the jungles, the crevices of the rocks, and the various byways which the mammals cared least to frequent, and that they have been kept there to this day. At first the mammals were not very different in habit or type from one another. Small animals which, like the shrews, moles, and hedgehogs, lived on insects were among the earliest. There were others whose toes were turning to hoofs in order to fit them for fleetness, and there were some curious creatures called coryphodons, which were like the modern tapir, though they were tusked like boars. The coryphodon was a slow beast, with toes like those of an elephant, though it was much smaller. In America appeared a small animal not much bigger than a fox terrier, which was the ancestor of the horse, and of which we shall have more to say. The birds increased, and forms like those of the heron mingled in the swamps with other goose-like birds that kept in their serrated bills some traces of the teeth of their early ancestors. Others, like kingfishers, flitted over the streams, and the emu, ostrich, and moa, as well as the albatross, find their earliest representatives in the Eocene times. It is impossible for us to follow, or even to enumerate, all the varied ancestral lines which sprang up, some of them already vigorous in the early Tertiary times, and which developed so mightily in the successive ages. We can only trace the careers of a few, such as are better and more popularly known, while admitting that there are many others equally interesting from a scientific or from any other point of view. From a geologist's point of view, the most important, perhaps, of all the mammal developments was that of the elephant. The first mammal which geologists discovered that was like the elephant was the mastodon, the American variety of which is called tetrabelodon. But this mastodon had no proper trunk, as has the elephant. Instead of that, he had a very long upper lip, which apparently rested on his projecting upper tusks. Mr. Kipling once suggested that the elephant's trunk was originally formed by an accident, an unfortunate young elephant before the days of trunks having stopped to drink at a pool, and his nose being seized by a crocodile, who pulled and pulled till the nose lengthened out a trunk. There certainly was some reason for the elephant's trunk, which has developed, we do not quite know how, from a long nose. But a great deal has been found out about the early development of the elephant by Dr. Andrews of the British Museum. Dr. Andrews was traveling in Egypt some years ago, and joined a party of officers of the Great Survey of Egypt in a visit to the Great Western Desert, the rainless sandy waste west of the Nile, not very far from what is now called the Fayoum, and where, in Roman days, was the great Lake Moeris, now dried up to a mere brine pool, in the salt water of which the fresh-water fishes of the Nile still live. The surveying party intended to determine the geological age of these sands, which stretch for hundreds of miles, often rising into cliffs which are cut sharp by the wind and show horizontal stratification. The geologists determined that the sands of this region were of Eocene and Miocene age, and from them Dr. Andrews brought home some very interesting bones. These included the remains of a more primitive mastodon than any as yet known, and of an animal which he called Merotherium, which is a connecting link between elephants and other mammals. The collection included also remains of great flesh-eating beasts, and of sea cows, of tortoises, and of a snake 60 feet long. However, in regard to the history of elephants, the upshot of Dr. Andrews' most important discoveries is that we find living here in the Upper Eocene period, which is older than the age in which the Tetrabelodon mastodon was found, an elephant ancestor of the kind to which Dr. Andrews gave the name of Paleomastodon or ancient mastodon. We thus arrive at an ancestral elephant-like creature which serves to join the elephant's stock on to more ordinary mammals. This beast was not so very big, perhaps about the same size as an ordinary cart horse. Dr. Andrews' further triumph was the additional discovery of the rather smaller animal, which he called the Merotherium, and which was undoubtedly an elephant of sorts, though at first sight it has no resemblance to one, and probably had no trunk at all. It certainly had no big tusks, but its teeth make us certain that it belonged to the elephant family. Here, then, says Sir E. Ray Lankester, we have arrived at a form which undoubtedly was closely related to the ancestors of all the elephants, if not actually itself that ancestor, and in it we see the origin of the elephant's peculiar structure. From this comparatively normal pig-like Merotherium, the wonderful elephant, with his upright face, his dependent trunk, and his huge spreading tusks, has been gradually, step by step, produced, and we have seen some at least of the intermediate steps, the lengthening of the jaws and the increase in the size of the teeth in the Paleomastodon, carried still further on by the Tetrabelodon, and then followed by a shrinkage of the lower jaw, and final evolution of the middle part of the face and upper jaw into the drooping, wonderful prehensile trunk. The long-chinned elephant requires, however, a few moments' consideration from an altogether different point of view. This species appears to have had the widest geographical distribution of any member of the family, of which it may be regarded as the great colonizing or emigrant representative. First developed in North Africa, where its remains occur in the early Miocene strata of Mogara and Tunisia, this species ranged right across Europe to the confines of northwestern India, having probably reached Italy from Africa by means of a land bridge by way of Sicily, and thence traveling through Greece into Asia. On the latter continent it appears to have given rise to the modern elephants, as remains of the former are unknown in any other part of the world. If this be true, it follows that elephants of the modern type subsequently migrated into Europe and thence to Africa, while in the other direction they wandered by way of Bering Strait to America. Here we are led to the remarkable conclusion that while the first elephants appeared in Africa, the modern African elephant is of Asiatic parentage, and a comparatively recent immigrant into the land of its forefathers. Next to man and the carnivora, elephants appear to have been the greatest travelers the world has ever produced. For, starting from their North African birthplace, they reached by the Bering Strait route nearly to the extremity of South America, while to the north they penetrated the Arctic Circle, and to the south on their return journey reached the coast in the neighborhood of Cape Town. Another great traveler was the horse. The first undoubted horse-like animal was Eohippus, a little creature about 11 inches in height at the shoulder, and in general rather more like the flesh-eaters than the horses of the present day. The back was arched, the head and neck were short, and the limbs of moderate length, showing no remarkable adaptation for speed. This genus had a remarkable range, having apparently originated in England, then a part of Western Europe, and migrated by way of Europe and Asia, and what is now Bering Strait, to America, where it got as far east as New Mexico. This migration of Eohippus shifted the scene of evolution to the Western Hemisphere, for while examples of it are continually and continuously found there, in succeeding strata it only appears occasionally in Europe, as if the remains there had been those of mere emigrants. Later on the horse developed in America, growing larger till it was first as big as a collie dog, with signs of being more adapted for speed. It then had 4 toes on its foot. It continued, though very gradually, to grow larger, and even more gradually its unnecessary toes grew fewer and fewer, till at last they disappeared. At length appeared the horse, which had only 1 toe. This type, that of the modern horse, first becomes known in the upper Pliocene beds of Europe, and represents the culmination of the race. The completeness of the record of the evolution of the horse tells us something of the enormous numbers of ancestral forms which must have existed in the more than 2,000,000 years that have elapsed since the first diminutive horse appeared in North America. While not strongly given to migration, in the course of time these animals wandered over the entire world, with the exception of such inaccessible places as Australia and the oceanic islands. It would seem that the original stock was of Eurasian derivation, though the great theater of the evolutionary drama was soon transferred to North America, the Eurasian, African, and South American horses, which appear from time to time, being in all probability of North American origin. The ultimate fate of the horses in both North and South America was extinction. All wild horses of our own time, including the asses and zebras, being confined to Asia and Africa. The apparently wild bands of the American western plains, and those which roam over the pampas of South America, are the descendants of domestic horses that have escaped from human bondage, largely from the early Spanish explorers. The rhinoceroses of today, the 1-horned Indian variety, and the 2-horned African rhinoceros, were preceded by a whole regiment of rhinoceroses in the Tertiary period. One such was dug out in Fleet Street during the excavation for the Daily Chronicle office. This rhinoceros had a hairy coat like the mammoth, which lived much later, and in Siberia is found sometimes side by side with the later quadruped. Many of the extinct rhinoceroses had two horns like the African square-mouthed rhinoceros, which is sometimes misleadingly called the white rhinoceros. One great extinct beast, the Elasmotherium, allied to them, had a great horn carried on a huge boss in the middle of its head instead of on the nose, while another still huger animal, called the Titanotherium and found in North America, had a pair of horns perched on either side of its nose. As large as the rhinoceros, but having a very different arrangement of the bones of its ankles and wrists, and very different teeth and horns, are the extraordinary creatures known as Dinoceras, whole skeletons of which have been disinterred from the Eocene strata of Wyoming in the United States by Professor Marsh. These creatures had 3 pairs of horns on the top of the head, and a pair of great tusks as well. Nearly all these animals, though they were more brainy than the reptiles, had much smaller brains in proportion to their size than the bulk of the animals which now roam the earth, from which we may surmise that though a small brain suffices to guide a great animal machine in established ways, yet in order to learn new things in its lifetime, an animal must have a big brain. The last great mammal we must mention in this series is the Arsinoitherium, which was found only a few years ago by Dr. Andrews in Egypt, in the same strata whence he obtained the fossil ancestors of the elephant. It was so called because it was found near the palace of Arsinoe, the name of the Egyptian queen of Greek race. But Arsinoitherium was far from being a graceful, ladylike creature, and, resembling in general appearance a rhinoceros, had 2 enormous bones which grew out of its nose on either side of it. The bones were hollow and were probably covered with skin in life, and Arsinoitherium had a wonderful and wonderfully even set of teeth. To conclude, we must add a representative mammal of this period, the Civatherium, found in India, and the Samotherium, found in the Isle of Samos, which were like giraffes, and the beginning of the sloth-like animals, whose appearance we must, however, deal with in another chapter. The whales, whose remains are found in the Pliocene rocks, differ little from those now living, but the observations geologists have been able to make upon these gigantic remains of the ancient world are too few to allow of any very precise conclusion. It is certain, however, that the fossil differs from the existing whale in certain characteristics perceptible in the bones of the skull. The discovery of an enormous fragment of a fossil whale, made at Paris in 1779, in the cellar of a wine merchant in the Rue Dauphin, caused a great sensation. Science pronounced, without much hesitation, on the true origin of these remains. But the public had some difficulty in comprehending the existence of a whale in the Rue Dauphin. It was in digging some holes in his cellars that the wine merchant made this interesting discovery. His workmen found under the pick an enormous piece of bone buried in a yellow clay. Its complete extraction caused him a great deal of labor and presented many difficulties. Little interested in making further discoveries, our wine merchant contented himself with raising, with the help of a chisel, a portion of the monstrous bone. The piece thus detached weighed 227 pounds. It was exhibited in the wine shop, where large numbers of the curious went to see it. Lamenon, a naturalist of that day, who examined it, conjectured that the bone belonged to the head of a whale. As to the bone itself, it was purchased for the Tyler Museum at Haarlem. Lastly, we must not omit to mention that in the Old World the first true apes, Aureopithecus and Dryopithecus, appeared. The first of these united some of the characteristics of apes and monkeys. The second, about the same size, was more closely related to the chimpanzee and gorilla. End of chapter 22. Chapter 23 of the Romance of Modern Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Rita Boutros. The Romance of Modern Geology by Edwin Sharpe Grew. Chapter 23. The Ice Age. For some reason or reasons concerning which there has been a great deal of speculation, but not a large amount of agreement, the closing stages of the last geologic era which precedes our own, and which links the great past to the present, were distinguished by great cold and by widespread fields of ice. Ice sheets spread over 6 or 8 million square miles of the earth's surface, where not long before mild climates had prevailed. Were it not for this great ice age, and for its far-reaching effects on the conditions under which man has developed, this period, which is sometimes called the Pleistocene, from Greek words meaning the most recent, would be more properly joined to the era which we have just been discussing, the two periods constituting a single period of great land elevation and of ocean shrinking. This period, however, is now thought to be much more important than it was formerly, and perhaps longer in duration. More than half of the ice-covered land lay in North America, and more than half the rest in Europe. The glaciation, therefore, was probably confined to certain parts of the world, and did not stretch all over the planet. But the whole world felt its effects. Even in tropical regions, ice and glaciers occurred on mountains where they did not exist before, and do not exist now. And on mountains which now have glaciers, the ice descended to levels 5,000 feet below the point where it now stops. The southern hemisphere was affected as well as the northern, but to a much less degree. In Patagonia and New Zealand, glaciers crept down from the mountains and spread out on the plains. Glaciers formed on the mountainous tracts of Tasmania and Australia, where none exist now. Most of the higher mountains of the southern hemisphere bore glaciers. The Antarctic regions were presumably buried beneath ice and snow as they are at present, but of that we are not certain. In Asia, ice fields far greater than those existing today affected the higher mountains, and from the Lebanon to the Caucasus and from the Himalayas to Siberia and China, traces of glaciers are found where they are not to be seen now. Yet on the plateaus and lowlands of Asia, ice sheets were far less extensive than in Europe and in North America. In Europe there were large glaciers in the southern mountains and extensive ice sheets on the southern plains. Radiating from the Scandinavian highlands, a succession of great ice sheets crept forth on the lowlands of Russia, Germany, Denmark, Holland, and Belgium, and crossing the shallow basin of the North Sea, touched the shores of Great Britain, where they were met by ice radiating from the mountains of these isles. From the Alps, gigantic glaciers descended to the lowlands in all directions. Then the Rhine glacier moved out far beyond the mountains and joined with the glaciers of Savoy and Dauphiny on the plains of France, while from the southern Alps glaciers invaded the fertile plains of Italy. Glaciers of similar size and extent descended into the valleys of the Rhine and Danube, the Pyrenees, some of the higher mountains of the Spanish plateau, the higher mountains of France, the Apennines, the Carpathians, the Balkans, the Urals, all had their ice sheets. Iceland and the Faroe Islands were buried under ice, and even Corsica had snowfields and glaciers, some of which were not small. Nearly one half of North America was buried in ice. Strangely enough, it was not the whole northern half, but the northeastern half that was specially ice invaded, and, more strangely still, not so much the mountainous portions, though these were affected, as the plains. Alaska was largely free from ice except on or about the mountains, and there was less ice on the western plains than in the valley of the Mississippi. Much the greater part of the 4,000,000 square miles of ice field lay on the plains of Canada and in the upper Mississippi Valley. The Missouri and Ohio rivers, like two great arms, embraced the borders of the ice fields to which they owe their origin. We do not propose to examine the several theories which have been proposed to account for this extraordinary cold, for none is completely acceptable or accepted, but we may just mention them. Dr. Croll, a century ago, suggested that the cold may have been due to the alterations in the shape of the earth's orbit, alterations which astronomers tell us take place regularly, though very slowly and at intervals of millions of years. If so, this glacial period was only the last of many glacial periods, the traces of the earlier ones having, however, been for the most part obliterated and destroyed. Sir Charles Lyell has urged that geographical changes, elevations and subsidences, would of themselves be sufficient to bring about a glacial period, which, he says, would be the result of a great continent being formed round the North Pole, while oceanic conditions prevailed at the equator. Another theory is that the heat given out by the sun is not always equal, being sometimes more, when even polar countries enjoy a warm climate, and sometimes less, when only the equatorial regions are habitable. The objection to this theory is, of course, that we have no proof that our sun is of greatly variable heat. Whatever may have been the cause of the glacial period, we know as a proved fact that a long time ago, as measured by years, although the event itself is among the latest of the many changes recorded in the geological history of the earth, the climate of the British Isles was so intensely cold that the greater part of this country was covered with ice and snow. And we know also that this intense cold was sufficient to change in many respects the habits and appearance of the animals and vegetation of the earth. How much this was the case can be gathered from the fact that in the period which preceded it, animals which now live in the tropics roamed in the Arctic Circle, and figs and magnolias grew in Greenland. The last word we shall have to say on the climatic conditions of this period is that the Ice Age had its sub-periods and divisions, like all other epochs, and in them the ice sometimes retreated, and consequently in parts of the earth where there had been snow and ice, and where there were to be ice and snow again, the wintry conditions retreated, for centuries perhaps at a time, and the valleys and plains basked during these intervals in sun and rain and warmth. These epochs are called interglacial epochs. The life of the regions not much affected by the rigors of snow and ice is gradually being ascertained by geologists now. One of its most marked features was the retreat of the northern and Asiatic animals before the advancing ice towards the warmer tropics and equator. These animals journeyed back northward again whenever the retreating ice would let them. The great proboscideans, the mastodon and the mammoth, were members of this group, and so were the bear, the bison, the musk ox. With these mingled towards the south several types, which were gradually becoming extinct in North America, such as the horse, tapir, llama, and the saber-toothed cat. A second prominent feature was a southern group in the Western Hemisphere, consisting of gigantic sloths, armadillos, and water hogs. And now, for the first time, the interest of animal life shifts to South America. There are many instances, says Sir Edward Ray Lankester, in his book on Extinct Animals, quote, in which small living animals were represented in the past by gigantic forms very close in structure to the little living beasts, but of much greater size. Hence it is concluded that these particular living animals are the reduced and dwindled representatives of a race of primeval monsters. There is some truth in this, as may be seen from the history of the living sloths and armadillos of South America, as compared with the extinct gigantic sloths and armadillos dug up in that country. But it is a great mistake to conclude from this that it is a law of nature that recent animals are all small and insignificant as compared with their representatives in the past. That is simply not true. Recent horses are bigger than extinct ones. Recent elephants are much bigger than their earlier elephantine ancestors. There never has been any creature of any kind, mammal, reptile, bird, or fish, in any geological period we know of, so big as some of the existing whales, the sperm whale, the great rorqual, and the whalebone whales. It is true that there were enormous reptiles in the past, far larger than any living crocodiles, standing 14 feet at the loins, and measuring 80 feet from the tip of the snout to the end of the tail. But their bodies did not weigh much more than a big African elephant, and were small compared with whales. So let us be under no illusions as to extinct monsters, and proceed to look at those of South America with simple courage and confidence in our own day." End quote. The peculiar productions of South America in the way of animals appear to be the members of the group of mammals called Edentada, found nowhere else. When, however, South America, which once was an island, joined on to North America, numbers of animals, mastodons, horses, tigers, and tapirs, emigrated from north to south, and perhaps proved too much for the aboriginal or native beasts. At any rate, all the big South American mammals died out, and now there are left only the small tree sloths, the small armadillos, and the strange-looking ant-eaters. But in quite late geological deposits of South America we find the bones of gigantic armadillos and of gigantic ground sloths, which lasted on till the time when man appeared on the scene. The Glyptodon, of which there were several different kinds, was an enormous armadillo, as big as an ox. Like their small, puny modern descendants, they carried on their backs a hard case of bones, something like the shell of a tortoise. The modern armadillo's shell, however, is jointed so that the little animal can roll itself up into a ball. And in this direction, therefore, the armadillo, though it has decreased so much in size, has advanced in adaptability. The Megatherium was nearly as big as an elephant, and its skeleton, though so much larger, is very similar to those of the small sloths of present-day South America. Its teeth also are very much like theirs. But whereas the living sloths climb trees, as they have learnt to do, the Megatherium's method was more primitive, though quite as effective. It stood on the ground and pulled the trees down in order to eat the young branches. The Mylodon, which lived at the same time, was not so big, and its habits were similar. It had a number of little bony pieces scattered in its skin in the region of the back, like the pieces forming the bony case of the ancient armadillos, but the pieces in this case were not closely fitted together. It was supposed that the Mylodon, like all the peculiar gigantic animals of South America, had become extinct as long ago as the mammoth, of which we shall say more presently, or of the woolly rhinoceros which used to haunt Fleet Street. All these extinct South American animals were distinguished by peculiarly shaped teeth, and had no teeth at all in front. They are called, therefore, edentada, and their representatives today are much smaller. But some years ago Dr. Nordenskjöld, a Scandinavian traveler, while exploring in Patagonia, found a vast cavern called the Ultima Speranza Cave on the western coast. From this cavern the settlers who lived close by had removed an enormous piece of skin covered with greenish-brown hair, and studded on its inner side with little knobs of bone. The skin was dry but sound. When it was placed in water, it gave out a smell which, though unpleasant, was very interesting, for it showed that the animal which had worn it could not have been dead thousands or even many hundreds of years. It was, in fact, evidently a piece of the skin of a Mylodon, which had survived in this region until modern times. Further explorations were made in the cavern by Dr. Moreno of La Plata and other naturalists, and an immense quantity of bones was obtained, and more portions of the skin of Mylodon with the hair on. The cavern had been inhabited probably several centuries ago by Indians, for human bones and weapons were obtained. The remains of as many as 20 Mylodons have been obtained from the cavern, and many of the bones are cut or broken in a way which leads us to suspect that the human inhabitants of the cave cut up the dead Mylodons for food, and split their bones to obtain the marrow. Some of the Mylodon bones, skulls, jaw bones, leg bones, etc., are smeared with blood and have pieces of cartilage and tendon attached. There are other evidences which go to show that the Indians may have kept the Mylodons alive in the cave and fed them with hay brought from the outside. Anybody who would care to see the last of the great extinct animals can inspect some of these remains at the Museum in Cromwell Road, London. Besides the relics of the Mylodon and of man, the cavern has yielded bones and teeth, and many horny hoofs belonging to a kind of extinct horses, and this constitutes one of the puzzling things about this cave treasure. The cave is in a part of the country very difficult to reach, and though Sir Thomas Halditch and Mr. Hesketh Pritchard made efforts to reach it again and explore it systematically and scientifically, there is a great deal about it that seems likely to remain unexplained. The bones that were found are not buried in lime or any preserving stone, but lie in sand, where one would expect them to have perished long ago if they had been of any great age. Yet side by side with them are the bones of a long extinct horse, and there is no tradition among the Indians today of any huge beast corresponding to the Mylodon. Sir E. Ray Lankester has pointed out that the whole of South America has been submerged and has risen, and is rising still, for many centuries. Possibly the rocks and highlands where the Mylodon cavern occurs formed an island during the submergence, where a number of early animals took refuge and survived until the re-elevation of the land, and so lived on in the present condition of the land's surface until 50 or 100 years ago. The great land tortoises, like the Galapagos tortoise, have similarly survived on a few equatorial islands. Possibly, though it does not seem very likely, the Mylodon is still living in similar caverns in this region, as yet unvisited by man. In Australia, the land of the marsupials, or mammals with pouches, the bones of many gigantic creatures belonging to that tribe of animal have been found. Giant kangaroos, twice as tall as the biggest living kangaroo, wombats and voles as big as a rhinoceros have been discovered. One of these is the Diprotodon, which Sir Richard Owen reconstructed much in the same way that he reconstructed the moa, and of which Dr. Stirling has since found complete specimens in a morass in South Australia. Last of all the great extinct mammals which we shall mention is the mammoth, which has a peculiar interest because, like the Mylodon, it certainly survived until man was on the earth, as there are many more evidences to prove. In one of the caves of France, inhabited by prehistoric men, and thickly strewn with the chipped flints which they used as tools and weapons, as well as with the bones of extinct animals which they ate, a piece of mammoth's tusk has been found on which is rudely but cleverly carved, evidently by the men who lived there, the picture of a mammoth. There are besides antlers on which a reindeer is very cleverly and artistically outlined. Even the tuft of hair below the chin is shown, and the great feet and the extra toes are correctly pictured. Clearly the men who drew this reindeer lived with the reindeer, and besides the reindeer, living near these men in the south of France, was the great mammoth. The mammoth was like an Indian elephant, but with a coarse, hairy pelt. It was rather bigger than the big Indian elephant, and its tusks had a different curvature. But we may dispose of the popular idea that it was bigger than any elephant. No Siberian mammoth has yet been found higher at the shoulders than 9 feet 6 inches. Whereas the African elephant stands 11 feet and sometimes more at the shoulders. Among the fossil elephants of southern Europe and of North America, Elephas imperator, there are 2 which stood from 12 to 13 feet high. The remains of the mammoth are left all over the north of Europe and Asia, and of the countries which were subjected to glacial influences. Even in England its teeth and tusks are constantly found, and in the Natural History Museum there is a whole skull with enormous tusks, which was dug up in a brickfield at Ilford. Probably this animal continued to exist longer in Asia and Siberia than in our own part of the world, and the cold and ice preserved their remains so well that whole carcasses have been dug up. One such instance is historic. In 1799, a native chief near Lake Ankul in Siberia, while seeking for mammoth teeth, perceived a great shapeless mass among the ice. He watched it for some years, till at the end of the 5th year the ice melted and disclosed the carcass of a whole mammoth. In the month of March, 1804, Shumakov cut off the horns, the tusks, which he exchanged with the merchant Boltonov for goods of the value of 50 rubles, not quite £8 sterling. It was not till 2 years after this that Mr. Adams, of the St. Petersburg Academy, who was traveling with Count Golovkin, sent by the Czar of Russia on an embassy to China, having been told at Yakutsk of the discovery of an animal of extraordinary magnitude on the shores of the frozen ocean, near the mouth of the river Lena, betook himself to the place. He found the mammoth still in the same place, but very much mutilated. The Yakuts of the neighborhood had cut off the flesh with which they fed their dogs. Wild beasts, such as white bears, wolves, wolverines, and foxes, had also fed upon it, and traces of their footsteps were seen around. The skeleton, almost entirely cleared of its flesh, remained whole, with the exception of one foreleg. The spine of the back, one scapula, the pelvis, and the other 3 limbs were still held together by the ligaments and by parts of the skin. The other scapula was found not far off. The head was covered with a dry skin. One of the ears was furnished with a tuft of hairs. The balls of the eyes were still distinguishable. The brain still occupied the cranium, but seemed dried up. The point of the lower lip had been gnawed, and the upper lip had been destroyed so as to expose the teeth. The neck was furnished with a long flowing mane. The skin, of a dark gray color, covered with black hairs and a reddish wool, was so heavy that 10 persons found great difficulty in transporting it to the shore. There was collected, according to Mr. Adams, more than 36 pounds weight of hair and wool, which the white bears had trod into the ground while devouring the flesh. This mammoth was a male, so fat and well fed, according to the assertion of the Tungusian chief, that its belly hung down below the joints of its knees. Its tusks were 9 feet 6 inches in length, measured along the curve, and its head without the tusks weighed 414 pounds avoirdupois. Mr. Adams took every care to collect all that remained of this unique specimen of an ancient creation, and forwarded the parts to St. Petersburg, a distance of 11,000 versts, 7,330 miles. He succeeded in repurchasing what he believed to be the tusks at Yakutsk, and the Emperor of Russia, who became the owner of this precious relic, paid him 8,000 rubles. The skeleton is deposited in the Museum of the Academy of St. Petersburg, and the skin still remains attached to the head and the feet. A very curious example of the Siberian mammoth was discovered only a few years ago by a Lamut of one of the Arctic villages, and through the energy of Dr. Hertz was eventually removed in pieces to St. Petersburg. In the Zoological Museum there, the reconstructed mammoth now crawls out of a huge pit, for it was by falling into a pit that this fine beast met his death hundreds of generations ago. It was sunk in frozen ground, and this cold storage treatment had preserved it in an extraordinary manner. If the Siberian natives who discovered it partially buried in alluvial deposit had not uncovered it, so that the sun was able to play on the carcass and produce decay, this wonderful primeval monster might almost have been got out whole. As it was, the frozen ground had so kept the remains that Dr. Hertz found well-preserved fragments of food between the teeth, and the remains of a hearty meal in the stomach. There is no doubt that the mammoth fell into the crevice or pit, and damaged himself so much in the fall that he could not crawl out. One cannot help feeling some relief that he died after a short death struggle. A good deal of the very old meat of this body was eagerly eaten by the native dogs. End of chapter 23. The Ice Age.
Chapter 24 of the Romance of Modern Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betty B. The Romance of Modern Geology by Edwin Sharpe Grew. Chapter 24. The Kingdom of Man. The greatest zoologist of his time, Sir E. Ray Lankester, has said that man has differed from all other inhabitants of the animal kingdom in being able to resist the pressure of circumstances which have altered and destroyed them. In all the cases of the animals which we have been considering, these creatures have been limited by the conditions of geography. They have been killed by extreme of heat and cold. They have been subject to starvation if one kind of diet were unobtainable, and they have constantly altered in shape, structure, and appearance, according to the requirements of the new conditions in which they found themselves. But man's mind and will have enabled him to cross rivers and oceans by rafts and boats, to clothe himself against cold, to shelter himself from heat and rain, to prepare an endless variety of food by fire, and to increase and multiply as no other animal without change of form and without submitting to the terrible acts of selection wielded by ruthless circumstance over all other living things on this globe. And as he has more and more obtained this control over his surroundings, he has expanded that unconscious protective attitude towards his mature offspring, which natural selection had already favored, and established among the mammals into a conscious and larger love for his tribe, his race, his nationality, and his kind. He has developed speech, the power of communicating, and above all, of recording from generation to generation his thought and knowledge. He has formed communities, built cities, and set up empires. And at every step of his progress, man has receded farther and farther from the ancient rule exercised by nature over the lower animals. Whence comes this power? When and how did it arrive? That we do not know. For the early beginnings of man we can only grope among the relics of his progress, which he has left for the speculation of his more intelligent descendants, in the shape of the rude implements and dwellings which he used in the childhood of the race. From time to time actual remains of early man are found buried among the uppermost strata, and from them we can make some guesses as his age. Virtually 3 links have been found in the chain of human ancestry. The earliest is represented by the Trinil man of Java, found by Dubois in 1890, and named the Pithecanthropus erectus, in reference to its likeness both to man as we know him and to the great anthropoid apes, although it had a much more erect carriage than any of them. This relic, man or some other creature as it may have been, stands midway between the chimpanzee and the more typical Neanderthal man, the skull of which was found in a cave of the Neander Valley near Dusseldorf in 1856. 30 years later, the skulls of the spy men of the same type as this were found in Belgium. This type lived in what we call the early Stone Age, and was a low type of meat-eating hunter. The next higher type, the third type of man, is that identified with what geologists and anthropologists call the Gibraltar skull, from the place where the skull was found. But all we know of these types of man we must judge from their skulls and from the stone implements and the animals found near them. The skulls of primitive men and of modern men show a certain difference in shape. If we take 2 skulls, that of a man and a monkey, and draw a line from the region just over the nose to the place at the back of the skull, just above where it joins the backbone, there is left above the line a great dome in the human skull, whereas in the monkey the place left above is much flatter and much shallower. Now the skull of the Pithecanthropus erectus found in Java resembles the monkey's skull in this shallowness, and the skulls of the Neanderthal and the spy men also had shallower brain pans than the men of today. They may, therefore, be either different creatures or they may merely have had smaller brains. We can only say that the creature called man suddenly appears among the lower animals with a brain some 5 or 6 times the bulk, in proportion to his size and weight, of that of any surviving ape. Great as is the difference, it is one of the most curious facts in the history of man's development that the bulk of his brain does not seem to have continued to increase in any very marked degree since the early ages of stone. What were the Stone Ages? In the long years before primitive man learned to weld iron or bronze, he formed his weapons and his tools from stone and flint, and geologists and antiquarians have discovered several of these ages of stone of different periods. For example, the Stone Age which our grandfathers spoke of is now called the Neolithic Age, and in the second quarter of the last century it became gradually admitted that man had existed earlier than that and had swung hammers and chipped edges in what we now call Paleolithic times. That would put man back to the age of the mammoth. But in the last quarter of last century a new claim arose. The Paleolithic stone weapons and tools were made 150,000 years ago, and were manufactured with great skill and even artistic feeling. Within the last 10 years much rougher flint implements of peculiar types have been found in gravels which are 500 to 700 feet above the level of the existing rivers, in the drift of which Paleolithic implements were found. To these older, clumsier weapons and tools, if indeed implements they be, the name eoliths was given by Mr. J. Allen Brown. These eoliths of the south of England and of Belgium indicate a race of men of less developed skill than the makers of the paleoliths, and carry the antiquity of man at least as far back beyond the paleoliths as these are from the present day. So much for speculation. But are the eoliths truly implements, or are they, as a determined school of anthropologists assert, merely flints which fortuitously resemble the rougher variety of true paleolith? The strongest attack made on their authenticity comes from Professor Boule and Monsieur Laville of the French School of Mines, who say that in the flint waste of a cement factory at Mantes they have discovered pseudo-eoliths, which are made by the action of the water of the mill, and which resemble every known variety of the so-called eolith. Their suggestion is that eoliths were not made by man at all, but were produced by the action of running water. To which the eolithic anthropologists retort that eoliths ought surely to be produced by running water now, and that some Seine-made eoliths would be more convincing. The differences between the Mantes specimens and the true eolith cannot be detected by the untrained eye, but, spite of the French skeptics, the school of believers in the genuineness of the eolith is growing. We need not enter further into these controversies, and we need only say that flint implements of various kinds are found all over the world: in Egypt before the Pharaohs, in Australia, in South Africa, and indeed in every continent. They are being made even today by aborigines in Australasia, and there is even a flint knapping industry which survives today at Brandon, in Suffolk, though these flints are not intended for use as spearheads or arrowheads or anything so primitive. There is little geological evidence to show the place where man first appeared, but what we know of his frame and constitution induces us to believe that somewhere in the warm climate of southern Asia was his first habitation. From this, or from some similar tract in that quarter of the globe, there seems to have been 4 great migratory movements. These were complicated by reverse movements, by cross migrations, and by wanderings, which we shall probably never altogether understand, and so we can only sum up briefly the chief features of them. The greatest movement appears to have been northeastward, between the great desert and mountain tract of Central Asia on the one hand, and the Pacific on the other, attended by divergences eastward to many islands, as they are now of the Pacific. When the emigrants got too far north to wish to explore further, they spread out to east and west, forming a belt below the Arctic regions and sending a branch down the whole length of the American continent. This movement embraced the Mongoloid races and included the old American Indians and the Malayan races. Before the disturbing influences of man's later development, this branch had three notable centers of civilization: the Chinese in Asia, the Mexican in North America, and the Peruvian in South America. A second and much less numerous band of emigrants struck out to the southeast, and reaching the southern hemisphere gave rise to the Australian and New Zealand aboriginal races, all peoples who never rose very much or developed notable power. To a third movement to the southwest is assigned the peopling of Africa south of the Sahara with the Negro and similar races, which have become very numerous but never very powerful or intelligent. The fourth movement was northwestward across or around the barriers of desert and mountain to Western Asia, Europe, and North Africa. These emigrants were the true adventurers, hardy, progressive, and energetic, and their descendants have developed into the strongest and most vigorous of the human family. The less progressive of them remain still on the further side of the mountains of Western Asia. The three passageways used by the original emigrants seem to have been: 1. The Red Sea Nile Valley path, in which the dusky white and the Ethiopian races mingled; 2. The Euphrates Valley, down which the Semitic races moved; and 3. The tracks of the more northerly plateau, across which moved the ancestral Aryan races. It is also quite certain that some races moved backwards by this route and returned to India to give rise to the Brahmins, the most learned race of that country. We have thus traced, so far as our limited knowledge will allow us, the geographical spread of man's dominance, but we cannot associate him with the history that in previous chapters we have roughly traced, of the development of the lower members of the animal kingdom. The qualities which have developed in man are of such an unprecedented power, and so far dominate everything else in his characteristics and surroundings, that they justify the view that he forms a new departure in the gradual unfolding of this world's predestined scheme. Knowledge, reason, self-consciousness, will, are the attributes of man. He goes on from strength to strength, and in the divine purpose which created him may lie the possibility that in the future he may attain a fuller knowledge than any he yet possesses. The great poet of the Victorian age wrote of knowledge: "Flower in the crannied wall, I pluck you out of the crannies. I hold you there, root and all, in my hand. Little flower, but if I could understand what you are, root and all in all, I should know what God and man is." The nearer approach to that understanding is the greatest and truest aim of scientific investigation. End of chapter 24. End of The Romance of Modern Geology by Edwin Sharpe Grew.